Now on page 11, we've got two proofs. We're actually going to do four proofs today. We're going to do pages 11 and 12 in the notes. So if you look at number 55, definitely the left-hand side is more complicated. So I'm going to go ahead and start with the given on the left-hand side. So the strategy that we're going to use on this one is turn everything into sines and cosines. One reason we know that that's the strategy is because if you look at the right-hand side, it has a sine and a cosine. So we're going to turn everything on the left that's not already a sine and a cosine into something with sine and cosine. And we're going to do that using the quotient property. So if you look at tangent theta here and cotangent theta here, we're going to use the quotient property to turn those into things in terms of sine and cosine. Tangent is sine of theta over cosine of theta. And then cotangent is the reciprocal, so it's cosine of theta over sine of theta. Now, the strategy we're going to use next is actually instead of like finding a common denominator, we are going to change each of these fractions, excuse me, individually, so that they aren't complex fractions. So what we're going to do is change each of these so that they don't have fractions within fractions. So if you look at the first fraction, the fraction within fraction has a denominator of cosine. So what we need to do is multiply the top and bottom of this fraction by cosine of theta. That will get rid of the fractions and fractions. The second one, we're going to multiply by sine of theta over sine of theta because that will get rid of the fractions within fractions. So it's the fraction buster, the common denominator of each fraction. So now, if you look at this, what we're going to do is distribute the cosine on the left-hand side to both things so that the numerators become cosine squared. The denominator, make sure you distribute the cosine to both things. So 1 times cosine is cosine of theta, and then sine over cosine times cosine, the cosines cancel. That's the whole point of why we're doing this, and you get sine of theta. The second fraction, we're going to distribute sine of theta inside. So we get sine squared in the numerator. And then the denominator, we're going to get 1 times sine, which is sine of theta, and then minus cosine of theta because the sine of theta is canceled. That was all just algebra. Now, if you look, we kind of have a common denominator, but not quite. They are opposites. So I'm going to go ahead and keep the first fraction the same. But the second fraction, so that I get a common denominator, I'm going to multiply the top and bottom by -1. And so that's going to now become a negative sine squared of theta. And then the denominator, when you multiply by -1, the sine of theta is going to become negative. The negative cosine will become positive. So then you'll have cosine of theta minus sine of theta. That was all just algebra. Now that we have a common denominator, we can put the two fractions together. So your numerator is going to become, sorry, readjusting all this. Your numerator is going to become cosine squared of theta minus sine squared of theta. Now that's not a property. Remember, it's cosine squared plus sine squared. That's a property. So actually what we're going to do next is factor the numerator. So this was just algebra. Now we're going to factor the numerator. The numerator is a difference of squares. So the numerator is going to factor to cosine of theta plus sine of theta times cosine of theta minus sine of theta, which one of those factors, as you see, is the denominator. So the numerator, one is going to be plus, one is going to be minus. It's difference of squares pattern. That's just algebra. And then look, your cosine of theta minus sine of theta are going to cancel. And then you're left with cosine of theta plus sine of theta. But if you look at the final answer, it's supposed to be sine of theta plus cosine of theta. So always make sure your final line is the other side of the equation. So you do need to rewrite it as sine of theta plus cosine of theta. And that's that one. Okay, now we're going to do number 61. And I've already written the given. The left-hand side is more complicated, so that's our given. The strategy on this one is the same as 55. We're going to turn everything into sines and cosines. Again, if you look at the right-hand side, it's in sines and cosines, so that's usually the best way to tell what to do. So we're going to use quotient property on both of these. And the quotient property for tangent is sine over cosine. The quotient property for cotangent is cosine over sine. So we're going to rewrite each of those individually with the quotient property. Now, similar to the last one, we're going to end up with complex fractions, fractions and then fractions. The difference, though, with this one and the last one is it's all one big complex fraction. And so we're going to multiply the entire fraction by its common denominator. So if you look at the four fractions, the common denominator between all four of them is cosine theta, sine of theta. So we're going to multiply the top and bottom by cosine of theta, sine of theta. And we're going to do the top and the bottom so we can multiply by 1. Make a little bit more room. Now, be careful when you distribute this. Realize we're doing this to get rid of the fractions within fractions so that we're going to distribute it all to the numerator and then everything in the denominator. So 4 different places. A quick way to do it in your head is think about dividing by the bottom first and then think what cancels and then multiply by the top. So that very first one, when you distribute, the cosines are going to cancel. So you're going to be left with sine squared. The second one in the numerator, the sines are going to be canceled. So you're left with cosine squared. The denominator is going to be exactly the same, except it's going to be sine squared plus cosine squared. So that was all just algebra by multiplying all of that. If that's hard for you to do, you can always do a bunch of side work to make sure you're doing it correctly. So if you look at the denominator, that is now a property. It's the Pythagorean property. So now the whole thing is being divided by 1. And you do need to show that division step of divided by 1 and say that's the Pythagorean property. And then if you look at the final answer, the numerator is what we're trying to get. So now you can just rewrite it without the divided by 1 and you're finished. And that's just algebra. Okay, now we're going to do number 69. And the strategy we're going to use on number 69 is to separate the fractions. So the left-hand side is more complicated. And if you can see, the numerator, if we separate the fraction, it's going to be able to be reduced. And then you'll see what happens from there. So rewrite the left-hand side. That's your given. And now when I mean separate the fraction, you're going to do secant of theta over the whole denominator and then subtract cosecant of theta all over the denominator. So it's kind of like getting a common denominator and then adding and subtracting your fractions, doing it in the backwards. So you're going to separate the fraction. Make sure when you separate it, if you put it back together, you have the previous line. So that's just algebra. And now we're going to reduce each of those fractions individually. So the left fraction, the secants of thetas are going to cancel. And the right fraction, the cosecants of theta are going to cancel. So we're left with 1 over cosecant of theta minus 1 over secant of theta. So that was all just algebra. And the next thing we're going to use is the reciprocal property. 1 over cosecant of theta is sine of theta. And then 1 over secant of theta is cosine of theta. That was the reciprocal property. We used it on both of them, and we're finished. So that's it for the notes today. Here's your homework assignment. Everything is on Canvas, and the link to the video is on Canvas also. Please make sure you try your hardest on this assignment, and I will see you all on Monday.